It still kind of boggles my brain. Base systems, number systems. So, for example, we're in decimal, okay? Most of the world is. That means we count in tens. For us, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are our digits, and we do things decimally. So 10 is equal to, and the reason that it's called decimal, deca, deci, Latin for 10, and because this symbol represents 1, 10. Our system is based on 10, and 10 represents that, and 20 just represents, I mean, obviously 2 tens, or two multiplied tens. It seems normal, everything I'm explaining, nothing new, right? But there's different number systems. For example, base 6. So we'd go 1, 2, 3, and we'd have 0. 0, 1, 2, 3, 4, 5, 10. And these are just Arabic symbols. You could totally use this, and this has no connection to decimal. There's 1 of the base number. So it's 1 times 6. The value is 6. You know, it's still 5 and 1. That's still the value, but it's represented in this, and then this symbol. In Senary, you could call it 20 as well, but the value would be 12. It would be my 10 fingers and then 2 ears. When 10 in decimal represents 6, so then 100 is 60. If you're still struggling to understand it, as I am, it's kind of hard to wrap your head around. We'll go to base 12, duodecimal. Duodecimal or dozenal. Duo, 2, decimal, 10, dozen, I mean a dozen. So duodecimal, I think that sounds the coolest. So it's base 12. So this is equal to, there's one base number plus 0 units, it's 12. That is equal to 120 in value. Because the Arabic system was written around a decimal system, we could use something like this that would better fit a duodecimal system. So we could go 0, 1, 8, 9, but we have 12, so we need 3 more, we need 2 more symbols to represent 10 and 11 that we can use so that we don't have to start doubling up digits. We'll go, I don't know, smiley face and heart. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, smiley face, heart. Smiley face equaling 10 in value and heart equaling 11. But we don't want to, we don't want to use those dirty decimals. So we got this. This is our duodecimal system. Just 2 more symbols to represent 10, 11. So let's say we want to represent, let's say, using my decimal words to describe this, let's say you got 60 pigs in a blanket. 60 pigs in a blanket, you're ready to eat them. You just want to write it out in duodecimal. We'll count it out. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oops. See, I'm stuck to my decimal. 14, 15, 16, 21, 22, 23. And since we're base 12, we're about to hit 24. 2 times 12 is 24, so we're gonna hit 20 in decimal, but no, it's 24. So we'd count it out. 24 is equal to, 24 in decimal in value. 24, that's the value, for you decimal brained people, that's the value of it, but it's using this symbol to represent 24 because it's base 12. So eventually, to describe my 60 pigs in a blanket, I would go all the way to this. And that represents my 60 pigs in a blanket. Using decimal, it would be like that, but using duodecimal, it is a 50. That's about it, and I'm gonna show you some examples that kind of make more sense. So because I'm using the Arabic digits, they're based around base 10. So it's kind of confusing. Let's use something like this. I've seen it in some places. So we'll go back to base 6. We could do something like this. Something more fitting because, yeah, something more ancient. So we go 1, 2, 5, and then 6. That's not very well spaced out. So we have 0, 1, 2, 3. Also 0 is kind of a modern idea. 0 wasn't really used because why would you need something to represent nothing, you know? So we got 1, 2, 3, 4, 5, 6. So then if we want to do 12, we go bar, bar. I mean, if we want to do, there's probably more symbols in this system, but I mean, if we want to do 12, if we want to do, I don't know, 7, we go bar, dot. You know, this fits a lot cleaner. So that's base 6. Something else that you guys are probably familiar with is, you know, we just had cenary, we had dozenal, now we got binary, which uses 0 and 1. I don't really know how counting in binary works, but it's base 2 by Latin or Greek for 2. I just watched an animation on how to count in base 10 using binary, and that just kind of broke my mind. Another time, maybe. Anyways, binary, it's also a number system. And then we got unary. It's base 1, the simplest. And all it is, I mean, it's pretty much just tally marks. So we got 1, we got 2, we got 3, 4, 5, 6. That's it in decimal. There it is. Yeah, that's number 2. Number systems, pretty radical in my opinion. Pretty crazy, you know? I always just assumed, you know, 10, that's the way the world works, that's the way the universe works, but no, you get to decide. It's subjective.